Ladies and gentlemen, welcome back. Chapter 5 takes us deeper into the world of trigonometry, and we're going to start with 5.1 using fundamental identities. Okay, we're going to be evaluating or simplifying trig expressions, and sometimes, pretend that r isn't there, with the aid of trig identities. Okay, first of all, we're going to evaluate all 6 trig functions. Alright, so we're going to be given 2 bits of information, and we have to come up with basically the others that we don't have. Now, in this case, it says find all 6, but granted, we've got 2 already, so we really only have to find 4. Alright, but here we go. Okay, the tangent is 3. Okay, now what's going to be important really to figure out first is what quadrants I'm in. So if tangent is positive, okay, I don't really care about the number specifically right now, but if it's positive, that means I'm in either quadrant 1 or quadrant 3. Okay. Cosecant, well, okay, he's negative and he uses the same signs as sine, no pun intended. And so if he's negative, he's either in quadrants 3 or 4. Well, of course, the commonality there is the 3. So basically, if I start putting a diagram together here, okay, I'm now going to be drawing down here in quadrant 3. Okay, now using either of these two guys, I can get 2 of the sides, and then if I don't have the rest of them, I can always use Pythagoras to get it. I'm going to start by using the cosecant just because I've got 2 solid numbers here. So I've got a root 10, which is my hypotenuse, and a 3, which is my opposite. So I'm going to put a 3 over here as my opposite, and I'm just doing this kind of on purpose because I know how it's going to turn out. Okay, and then I've got a root 10, but just draw it generically as you want. Okay, now again, remember that the hypotenuse is always a distance, so it's always positive, so any sort of negative sign's got to come from either your opposite or your adjacent. In this case, it's going to be opposite. Okay, so I've got root 10, I've got negative 3. If I use Pythagoras, I'll get 1, since he's going in the negative direction, it'll be a negative 1. We could have used tangent to get there as well, though, because technically it's 3 over 1. But it'd be negative 3 over, well, to get a positive 3, I'd have to use a negative 1 there. So, whatever your brain likes, you should eventually come up with that diagram. The angle we're using right here is x, so that means there's my x, effectively. And so now I basically want to figure out the other 4. Okay, now I don't have sine, so there's sine. And, well, easy thing to do is actually flip this guy, but of course you can go to the diagram either way. So negative 3 over root 10, after a little rationalizing, gives me negative 3 root 10 over 10. Okay, cosine we don't have, so let's include that in our list. Okay, cosine negative 1 over root 10. So again, after a little rationalizing, I should get negative root 10 over 10. Okay, I've got tangent already, so continuing on, cosecant, I've got that. Secant I don't have. So secant x. Okay, again, I can just flip this, but remember, sometimes it's nicer to flip the unrationalized version. So the unrationalized version would be root 10 over negative 1, which is a heck of a lot nicer than re-rationalizing this after you flip it. Finally, we've got cotangent, and again, either way you go about this, either flip the tangent or just go to the diagram. Either way, you should get a positive 1/3 in this case. So basically, the final answer is this list of the other 4. I don't know if the book's going to list it in their answers, but I don't need you to list ones that they've already given you. Alright, moving on. Okay. We're going to do a lot of simplifying expressions and actually a lot of other manipulations of this nature in this chapter. So remember all those identities, you're going to be in trouble if you don't have those things down. So here we go. Here's the basic rules for this though. Simplifying expressions, we're going to avoid fractions or answers and attempt to get a single term. Products are better than sums. So if I have something plus something else, I want to see if I can turn that into something times something else. Sometimes it might be possible, sometimes not, but I should at least give it a shot. Okay, so here we go. If I give you cotangent times secant, well, we can definitely clean that up a little bit. Okay, cotangent, well, I could do 1 over tangent, but again, good rule of thumb is to turn everything into sines and or cosines and see how it goes from there. So cotangent is certainly cosine over sine, and then secant is 1 over cosine. Okay, I know I'm saying it that way, but please, when you're actually doing your writing yourself, make sure you put the angle in there, the x's and stuff. Eventually, we're going to get into stuff where we're going to have 2 different angle measures at the same time, so it is going to be very critical to include the angle that you're talking about. So some of you guys are in a bad habit there, but try to correct that now. Anyway, here we go. So any simplification I can do here, well, certainly those cosines will cancel themselves out, and that gives me 1 over sine. Okay, again, one of my rules is avoiding fractions by answer, so even though that is fairly simple, of course, using our reciprocal idea, I can now turn that into a cosecant x, and really, if you get down to a single trig function, there's not going to be any simpler you can do. So there's a basic one. Let's get a little tougher. Alright, sine x secant x plus cosine x cosecant x. Okay, doesn't look overly nice, but let's again dive into it and see what we can do. Okay, so I've got sine x, again I'm going to lazy set up with 1 because looking at the rest of the stuff I definitely have some fractions about to show up. So secant becomes 1 over cosine. Okay. Now I've got cosine. Again, I'm going to use a fraction. And then cosecant becomes 1 over sine. Okay, well that looks fine and dandy. Hey, I've got sine over cosine, so really if I think of that as sine over cosine, that simply becomes tangent. That's kind of nice. And then cosine over sine, that becomes cotangent. Okay, but it doesn't seem like I do much more than that, so that seems pretty simple, but again, that's a sum. Let's try to do better. I'll make a smiley face just because I feel like it. Okay, so from here, maybe instead of going to the sine or cosine here, I'm going to leave it as the sine of x over cosine of x, kind of just condensing the fractions from the previous step, plus cosine x over sine of x. Remember, a sum is okay, but a product is better, because then it's only one term. Okay, so now common denominator of man comes out and slaps some stuff onto this. So sine of x on both sides here, and then of course cosine x on both sides here. Okay, I apologize if you're watching this on a very small screen. I'm writing small because there are a couple more steps I got to get done here. Anyway, here we go. Okay, so the left side becomes sine squared x. Okay, the right side becomes cosine squared x, which hopefully looks very, very familiar to you. I'm going to cheat a little bit here and condense it all over my denominator right now. So my denominator sine x times cosine x. Okay, well of course that becomes a 1 on top, and then I've still got my sine x on the bottom of my cosine x. And then, for space concerns, I'm going to horizontally here. Well, I've got 1 over sine, I can turn that into cosecant, and 1 over cosine becomes secant. So basically, as a final answer here, this guy could become cosecant x times secant x. And again, I can't really condense that any further, because if I flip one without flipping the other, it really just becomes a big mess. So that's a nice, pretty answer, believe it or not. Okay, the book is going to say frequently there's more than one right answer, but quite honestly, most of the time, one of them is usually better than the other. So there you go. Okay, the next few slides are going to basically be some things that you can do that may not be overly obvious when you're first looking at the problem, but things that can help the process along here when you're simplifying these things. Okay, so factoring, for instance. Okay, if I've got cosine squared plus cosine squared tangent squared, x, okay, well, certainly I've got cosine squared being a common factor. So I'm going to take him out, cosine squared x. Okay, and that leaves me, again, remember you're dividing by cosine squared, leaves you with a 1. And then pulling the cosine squared out of here leaves me the tangent squared. Okay, and then again, think about your Pythagorean identities. One of them was 1 plus tangent squared x equals secant squared x. So that little nugget helps me replace this cosine squared x, and then of course this substitution gives me a secant squared x here. Okay, and in case it's not overly obvious right now, I'm going to rewrite this as cosine squared x over 1 times, well, secant squared is 1 over cosine squared x. And this very, very, very conveniently works out to be a clean old number 1. Alright, and that's pretty much as simple as you can get with that thing, that's for sure. Okay, and so sometimes if you got two different terms, you might add them to subtract them. Admittedly, when you're dealing with fractions like this, you're going to have to do some common denominator kind of stuff. Again, first thing I'm going to do is make that plus and negative 1 to help me with some sign issues that might arise otherwise. But here we go. Okay, so 1 over secant plus 1, and then negative 1 over secant minus 1. Okay, so unfortunately, there's not much I can do as far as common denominators other than multiply these guys by each other. So secant x plus 1 on the right, and then I'm going to have to kind of cram this in, but secant x minus 1 on the left. Okay, so now my numerators are actually going to come out kind of nice, but here we go. I've got secant x minus 1 on the left, plus, and this is why I do this, negative 1 times secant gives me a negative secant x. That'll be nice. And then negative 1 times 1 gives me a minus 1. Alright, and then this gives me this whole denominator of secant x minus 1 times secant x plus 1. Alrighty. Now again, the nice thing about what we just did is I ended up with a positive secant x and a negative secant x, so they just go away. And my numerator is negative 1 plus negative 1, so I get a nice clean negative 2 there. In the denominator, okay, I've got secant x plus 1 and minus 1, so it's really a difference of squares sort of thing. So I can multiply this out using kind of an abbreviated FOIL and get secant squared x minus 1. Okay, now using the exact same Pythagorean identities as the last one, Okay, if I start out with 1 plus tangent squared x equals secant squared x, taking the negative 1 to the other side, or sorry, taking the 1 to the other side as a negative 1 gives me tangent squared x equals secant squared x minus 1. Okay, so there we go. We have a nice little substitution we can do there. So negative 2 over tangent squared x. And again, that doesn't look too bad, but again, I've got a fraction, and all the trig functions can be flipped upside down if necessary to create something that isn't a fraction anymore. So basically that's what I'm going to do there. Taking the negative 2 is still my coefficient, bring the tangent up, it becomes a cotangent. Don't forget the square, x, and again, there's not much more I think I can do with that. So there we go there. Okay, now there's a section of problems which I think are kind of interesting. It's basically a section designed to help you use the calculator to your advantage, give you a target that you're shooting for. So here it is. They want you to use the calculator first to graph the expression and then verify it algebraically. Okay, so if I type in my calculator y equals secant minus cosine over tangent, x for everything there, can I graph it? I get something that looks like this. Okay, this is from negative 2 pi to positive 2 pi here, and hey, you know what? That looks like sine of x. Okay, starting at the origin, going up to 1, back down, 1 full period within the 2 pi, well, that certainly looks like sine. So basically that's my target as I start manipulating this thing around. Okay, so just a question of what steps do I need to do to eventually turn this thing into a simple sine. And well, let's see what happens. Okay, well, first thing first is I've got 2 terms on top and 1 on the bottom. So what I like to do in a situation like this frequently is split it into 2 separate fractions. So my first step will be secant x over tangent x minus cosine over tangent. Okay, and eventually I'm going to turn these both into complex fractions. I know that makes many of your skins crawl, but here we go. We got 1 over cosine, and then tangent, of course, is sine over cosine. And both those cosines at the bottom will end up being kind of convenient. Alright, but then we got minus, okay, the cosine, well, I'm kind of stuck leaving him as cosine over 1. Tangent still, of course, is sine over cosine. Alright, so flipping these guys over, and I'm going to kind of do this without the room that I have. So again, the cosines will cancel here, so that leaves me with basically 1 over sine on the left half of my problem here. 1 over sine of x. Okay, don't have anything else going on here, so flipping this fraction up here puts the cosine on top to sine on the bottom, so I actually end up with minus cosine squared over sine. Alrighty. Okay, so common denominator, I'm going to go horizontally now for lack of room. I've got 1 minus cosine squared over sine. And using my Pythagorean identities, I can turn 1 minus cosine squared into sine squared. And hopefully at this point you're going, oh, okay, I get it. Because then if 1 power of sine cancels out with the 1 power of sine at the bottom, leaving me with simply sine. And again, that was my target, so I'm super ecstatic at that point. Alright, so here's another one of these. You may or may not want to actually see it, but here it is anyway. Blah, ha, 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 ha. Alright, so anyway, typing this in my calculator, generated something like that, and again, hopefully you immediately look at that and think, hey, that looks like tangent. So exactly, that's the graph, y equals tangent. So again, that just gives me my target to shoot for as I start manipulating this thing around. So the secant becomes 1 over cosine, and then I've got minus, and again, if you want to think of it as plus and negative cosine x, that's probably not a horrible idea, but personal preference sort of thing. So plus sine. Okay, again, common denominator man shows up and gives me a cosine on the right hand side, and then I'll try to squeeze in a sine x plus 1 on the left. Alright. Okay, upon doing that, my numerator becomes a sine of x plus 1, and then again plus a negative cosine squared. Okay, that may or may not have been helpful in this case, but there it is anyway. And in the bottom I have a fairly messy sort of thing. I've got a sine x plus 1 times cosine. And don't really need that in parentheses, but I think it just helps in this case. Okay, well, again, I've got this 1 minus cosine squared. I know it's a little messy because of the plus sign in the middle right now, but again, 1 minus cosine squared, that's the same thing as sine squared. So my numerator becomes sine x plus sine squared x. And then I've still got that very icky looking denominator. So sine x plus 1 times cosine x. Okay, now the good news is I can do one of my little tricks from earlier in this lesson and do a little factoring on top. So I can factor out my sine, leaving me with now 1 plus sine x. Okay, and then mysteriously on the bottom I have a sine x plus 1. And because of that great set of associative and commutative and all those fun properties, those two guys are equivalent because I can change the order of addition. So those guys cancel out. I'm going to go horizontally again for lack of room. Gives me sine over cosine. And hey, wait a minute. That's that magic thing that I can turn into tangent, which again was exactly what I was expecting. So there it is. Okay, so hopefully that makes a little sense. If not, of course, ask as many questions as you like in class when I see you. Alright, and here's our assignment, 15 different problems, a little bit of variety amongst them. Remember though, for those of you that need the extra practice, this is only a kind of a minimum sort of thing, I guess. You can kind of fill in some of those other odds if you need a little bit more practice on this stuff. It's probably not a bad idea. Anyway, see you in class.